So guys, we're going to look in there at the surface geometry sheet 2 from the DCG solutions book. So the first question there, plan and elevation are given. So you use the rebatment method to get the dihedral angle between A and B, and then it says get the dihedral angle between B and C using auxiliary views. So basically there are two different ways that you can get the dihedral angles between surfaces. So first thing I'll do, I'll colour in the line of intersection between A and B. So that's the line of intersection in the plan, that's the line of intersection in the elevation. I'd give it some numbers, so I'll just go 1 and 2, 1 and 2. So the rebatment method involves taking an auxiliary of the line of intersection. So put an XY line up there. So 2 is on the ground, 1 is up in the air. The height above the ground is 22. So that there's 2, that's 1. So this is the true length of the line of intersection. So that's the true length of the line of intersection. Now, the rebatment method then involves putting in a triangle. Now I'll try to use a colour here for this. So you put in a perpendicular triangle. So I'll put it in blue. Now it's small enough, admittedly, here. So you put in a perpendicular triangle that just fits in there exactly. Project it back down. And this triangle is made to fit in. So like there is the 3 corners of it are here. So that is our perpendicular triangle in blue. But the problem with this is we don't have the dihedral angle yet because it's standing up at an angle there. We're seeing it.
Apologies for the interruption. Could Natasha Lucid?
So you got to rebat it, and that's where the word comes from. You got to rebat it down onto the ground. So I'm going to swing this blue triangle down onto the ground to the horizontal plane. So now it's lying down flat, and now when I project it down it will get bigger. So it will now get bigger because we're seeing the true shape of it, and it's this much bigger. And that there now, that's the dihedral angle here, this front point here. Just try and put some arrowheads on that. So when it was standing up there like that, when it was inclined, that's not the true shape of it, but when you drop it down the ground, that there now is the dihedral angle between A and B here. So it's a nice, quick, tidy way of doing it. Now on the other side here then, we were asked to do a dihedral angle between B and C. So again there, I'll just colour in the line of intersection, call that 1 and 2, 1 and 2. So I want to take an auxiliary. So both of these methods start off the same. So instead of standing looking in at it like that, you're going to look sideways, perpendicular to that. So I put on an XY line, 2's on the ground, point 1 is 22, I set up in the air. So And yeah, so in this it doesn't make a difference anyway. So 1 is up high, 2 is on the ground. Oh yeah, I just noticed there I switched the numbering on this one. Sorry, 1 was up high and 2 was on the ground over here. So what we're going to do there now is we're going to look down along that line of intersection to see a point view of it. So when I look along that line of intersection, put an XY line here perpendicular to that. So that's XY1, this is XY2, and I'm projecting from here, so the last XY line back is where my distance is coming from. So you can see there 1 and 2 are the same distance, and that's why we get a point view of it. So that there is 1 and 2. And I'll just put a little bit of a dot, a pink dot on that as well, just to show it there. So that's the point view of the line of intersection. Now, what we need to do here now is just pick 2 other random points, and I'm going to pick them both on the ground. So I'm going to call that 3, that 4. They're on the ground. So when I project it up, that's both 3 and 4 on the ground. When you project them back down then in the auxiliary, they're on that line. So projecting from here, so the last XY line back, so 4 is the close one. Four is the close one, and 3 is the further away one. And our dihedral angle is here, so that's 3, that is 4, this is our dihedral angle. And if I was to measure that with a protractor, you would find that that angle here is the same as that angle over here as well. So both of them are the same angle, because this yoke is symmetrical. So that's done by rebatment, and that's done by auxiliary, but it's 2 ways of finding the angle between different planes. So moving on to 2. So whereas projections of a triangular base solid are given there, so it's triangular base solid, so this is the apex up here, so I'm going to call that point 1, and I'm going to call this point 2, so that's it on the 3D over here. So again, I'm going to colour in the line of intersection, I think it just makes life easier to identify the line of intersection. And I'll colour it in over here as well. Right. So there's our line of intersection. So it's always the same procedure. Step 1, take an auxiliary, get a true length of it. So there's my XY line, and so when I project up there, 2 is on the ground, 1 is up in the air. How high is it? It is 40 exactly, I think. So that there is the true length of the line of intersection. So the next move there now is to look along it and get a point view of it. So shoot it out there. So here's my XY line. So that was my first XY line is up there, then XY1, XY2. So same rules apply. Projecting from here, so it's the last XY line back. So this is how we get a point view of it, because the distance from 2 and the distance back to 1 are the same, and since we looked along it, then it gives us the same distance for 1 and 2 on the 1 line. So that there is the point view of 1, 2. The line of intersection there, I'll put a bit of pink around it. Then, same as we did the last time, using the same angles, I'm going to just project out here 2 more random points that I'm picking, so I'm going to call them 3 and 4 again. Now 3 and 4 are just points on the ground, like this. They're on the horizontal trace, or the ground of those triangles. So here's 3 and 4. Then you project them up at our auxiliary angle, and we're projecting from here, last XY line back. So again, 4 is the close one, and 3 is the further away one. So that's 3, that is 4, and this here is the dihedral angle between those two surfaces there. So that's 1 and 2 done. So we'll move on to 3. They're all fairly repetitive, and when you find they're getting boring, it means you know it. So the next one there says use the rebatment method to determine the dihedral angle between A and B. So the rebatment method to get the dihedral angle between A and B. So again, same procedure. That is the line of intersection, and here I generally just go with 1 and 2 for this. The more repetition you do, the easier, better chance there is that you'll remember it. So here's our angle and plan. Always work off the plan, really, I think, if possible. You can do it off the elevation, but okay. So when I project out here, again, 2 is on the
Can I have your
ground.
attention, please? Could class 6A come to the Jeep?
So 2 is on the ground. 1 is up in the air at a height of 28. So that is the true length of the line of intersection, and again there, throw a bit of colour on it. I'd also ident TL for true length. So we're looking along. That's the angle for our auxiliary. So this is the angle for our line of XY line. Now, we've it all set up now. So projecting from here, from the last XY line back. So this is my distance for 1 and for 2. So 1 and 2. That 1 and 2. That's our point view of the line of intersection. And again, in the same procedure, I am going to pick 2 random points on the ground here, and again I'm going to keep them fairly close now. Call that one 3 and that one 4, so that's them on the ground there, 3, 4, and when you project them down, they're on that line there. So last XY line back, so 4 is the close one, and 3 is the further away one. So 4 was the close one, 3 was the further away one, and that's our dihedral angle there. And the last one here then, question 4, just zoom the camera over. So the plan of a roof is shown here, and the surface C is inclined 40 degrees to the horizontal plane. Okay, now a hugely important thing to check is if the top of a surface is parallel to the line on the ground, it means it's horizontal in the elevation. So like I know that because that's parallel to that there, it's horizontal, and the same with all of them. So the top of that there is just chopped horizontally. Now if that was at an angle, it wouldn't be, there would be at different heights. So plan of a roof is shown there, surface C is inclined at 40 to the horizontal plane, complete the elevation of the roof and get the dihedral angle in between B and C. Okay, so angle C here, this surface is at 40 degrees to the ground. So I'm going to do an auxiliary. You could go in either direction here. I think I'll go up the ways anyway. Doesn't make a difference, like, so I'm going to project up here and the top of that up there, put an XY line, might take the XY line out a bit, alright. So that's our XY line. This is the point on the ground. Now look, I could give these numbers like 1, 2, 3, 4. So when I project out here, this is 1 and 2. And we were told that the angle was 40 degrees. So you need to get your protractor, put it down, go off at an angle of 40 degrees. So that's an edge view there of the plane. And when I project up 4 and 3 onto it, so that there is 4 and 3, so that's the height of them. So when I take that height there, I find that they're the height of like 21 or 21 and a half or something like that. So I want to just step that height up there. So 21 and a half about. So that is the height that I was looking for. So that's A, and this is where the left hand side is. So that's my slope at the left, and this is 0.4 up here, sloping down to 1 on the ground. And then 2, sloping up to 3. So that's surface B. We've got an edge view of A. and that's surface C. And then they said to get the dihedral angle between B and C. Okay, so the dihedral angle between B and C. So there's a lot in this question. It's a good question. So that's the line of intersection in plan. That is the line of intersection in elevation. Okay, so 4-1 is our line of intersection. I'm going to project down this way now, I think, for the auxiliary. So an XY line here. So 1 is on the ground. 4 is up in the air at a height of 22, I think I said. 21 and a bit. So that there is the true length of the line of intersection. Bit of colour. Keep the numbering, so that's 1 on the ground and that's 4 up in the air. So when I look along that, put on an XY line over here. And projecting from here, so the last XY line back the ways, and that's our distance for the point view. So 1 and 4 are the same distance. And when you look along 1, 4, so that there, 1, 4, that's the point view of the line of intersection. So now we just want to take some points on the ground. Don't have to be on the ground, but it's just a smart way to do it. So no, just to show you, they don't have to be like I could take them just randomly anywhere. It's just quicker to take the two of them in line with the direction that you're projecting in. So, but it doesn't have to be. It's just a smart way of doing it, I guess. So that's my 2 points on the ground. So I've already used numbers up as far as 4, so I'll call that 5 and 6. So that's 5 and 6 on the ground. And when I project them out here, and I'm taking my distances back, so 6 is the close one, and 5 is the further away one. Now, for being accurate, these are dangerously close to each other, but it's really more about the method than, like, you know, it's not so much the accuracy. It really is the method that you've used is correct. So that there's our dihedral angle between them. And the last thing they asked for then is a true shape of surface B. The true shape of surface B. Now, there's different ways one could draw that, but I think one way you could do it there is you could just stand it up, okay? Because we already have, like, the bottom line here is the true length, and if I was to stand that up, and I have the true length of 1/4. So look, I would just use the protractor here. Like, that's a sloping surface, but if we stood it up straight and plan, we'd see a front view of it then in the elevation. So, and this corner would just go straight up higher. That corner will just go up higher. Now, here's the thing. The more you know, the easier it is. If that is the true length of 1/4, I can swing that. I'll use a different colour here and I'll put this in blue. That there is the true length of 1/4. And I know the top of it is horizontal. Goes back down here. So that blue quadrilateral there, that 4-sided shape, that is the true length. Now another way I could have done this, or could have found that, is I could have just taken a side view here. That's the 2 points, that's the horizontal trace there. This is the top of it at a height of 21 and a bit. 21. So like that there is the edge view of surface B, and that, if I take that height there, when that stood up straight, like that height there should be the same as that height there, which it is. Or you could have rebatted that down onto the ground, so you could swing that all the ways over here, down onto the ground. Bring it back, and because they are hinging kind of similar to above, they that corner would move down to here and there. And if I was to draw it in blue again, it would be from there to there, down to this corner here, and back down to 1 there. So that would be done by rebatment down onto the ground there as well. So like that blue surface, that's it there, lying on the ground. That was the edge view of it. This was it rebatted down onto the ground and projected back in again, then parallel to the horizontal trace there. So there's a lot in that last question, yeah. That would be like a full leaving cert question there, really, just on this last one alone. So yeah, nice bit in that now. Good practice for you. Yeah, see you later.